I'm here today with Sastry Malladi, co-founder and CTO of FogHorn. Welcome.
Good morning. Thank you, Greg. We're happy to be here.
So FogHorn is known for Edge, obviously. So can you tell me a little bit about FogHorn's Edge offerings and what are the drivers behind it and how do businesses benefit from it?
Absolutely. So as you know, Greg, Edge itself, the term has been used quite a bit these days. But when we started the company about 5 years ago, Edge was nascent and new to people. And some of the reasons why we decided to do provide a solution in the Edge space is traditionally, if you look at the industrial space, manufacturing, oil and gas, any of these industrial spaces, these equipments have been producing tons of data, terabytes to petabytes of data. The traditional approach of being able to process that data by transporting all of that information into a cloud environment isn't going to cut it for many reasons. One is that there may not be any connectivity from where these machines are to be able to send to the cloud. Second, the amount of bandwidth that you will need to transport all of that data into a cloud environment could be cost prohibitive. And third, latency is involved. Many a times, people want to know in these plants when there is a problem that's happening before it happens, before it's too late. But the latency is involved to be able to transport all this information into a central location, cloud or otherwise, process it there, and then send the results back into Edge environment is too late. Potentially could be too late. And finally, last but not the least, is security issues. Many of our customers, many of these industrial customers are afraid to connect their machines, heavy machinery into any kind of internet or public cloud. So therefore, they wanted some sort of a local edge processing right where data is produced to derive actionable insights. So what FogHorn was founded was to solve exactly that problem, to offer a generic edge intelligence platform that can run in a constrained hard compute environments right at the edge, get all of the data from these different machines and sensors, process them, derive the insights so the businesses can take action on it, benefit from whether it's a business loss, whether it's a scrap reduction, yield improvements, and things of that nature.
Okay. So I have to say, it seems like there are so many players claiming to have edge solutions of one kind or another. How do you differentiate?
It's actually a good question. So having seen the traction we have seen now in the last few years, especially now everyone wants to be part of it. So a lot of people have come out and then they're offering what they call edge computing solution as well, but sometimes it's misleading because many of them who in fact, for example, provide edge infrastructure, it could be hardware, it could be a software orchestration layer. In some other cases, especially some of the bigger technology providers are coming out and saying they provide edge computing solutions too, but their definition is simply connecting to these sensors, acquiring the data, cleansing it, and then send that cleansed information into a cloud environment to process it there. That is still not true edge computing. How we differentiate ourselves is we are actually truly processing the data right at the source itself, combining traditional digital sensors like temperature, pressure, velocity, combining it with some of the modern sensors, audio, video, acoustic, vibration, fuse them all together, and then be able to process them right at the edge in the constrained environment, right? So we are able to do that we have several patents on the technology, invented a CEP, complex event processing engine from ground up, that can work on all of these different fused set of signals, as well as machine learning. And again, a lot of people think machine learning can't be done at the edge, but we've obviously shown to the world it can. The combination of machine learning AI and the CEP engine is what we've invented to run in this small footprint constrained environment to process directly at the edge. Not just cleansing, not just the infrastructure, but directly deriving insights at the edge. That's how we differentiate from a lot of these other players who claim to be also providing the same type of solutions.
So let me follow up on the topic of machine learning and artificial intelligence. Because a lot of our users, when we talk to them, they tell us that this is a hot topic for them. Among the, we ask them to rank their choices, and this always comes out at the top or sometimes near the top. But can you expand on that a little bit?
So absolutely. In fact, you're right, Greg, that these days it has almost become a household word or a buzzword, ML, AI, machine learning. But really, what does it all mean to industrial customers, especially at the edge environment? What do we mean by that, and how do you differentiate ourselves from reality versus what's just talking about it, right? In the industrial context, many a times the plant operator, for example, may have a tribal knowledge they have a hunch for when certain things go wrong. typically what could potentially be the reason for it, right? If that's the case, they can simply express certain patterns or certain information as to say, when this condition happens, maybe this is what the problem is. That's easy. That's not machine learning. That can easily be expressed through some sort of either a CP expression language that we have or some other thresholding. But many a times, that's not what happens in reality. Customers would simply say, well, my machine is failing, or I'm producing products that are defective, or something else is failing, or my process is not running efficiently. Can you predict what was causing these process failures, or what's causing these defects in the product, and how do you do that? This is where we apply machine learning. And again, as I mentioned before, typically people think machine learning can only be done in a cloud, big compute environment. That's not quite true. We've actually shown using our technology, we can, in fact, especially the inferencing and execution part of it, can be done in the edge environment itself. Machine learning, again, comes in many different forms. We support all types of model descriptions. There are a variety of different, whether it's a Python-based, whether it's Spark ML, RStudio, or different types of tooling. We support all of that with different standards like PMML and so on. So that's one part of it. But even in that case, normally what happens is when you build a model in a cloud environment, typically you almost always assume you've got infinite amount of compute available to you. That's not the case in an edge environment. So something has to give. So we go through a process called edgification. We edgify, we have a trademark for it too. We edgify models developed in a cloud environment to be able to effectively run efficiently in an edge environment. And that is done through a combination of both hardware-based acceleration and a software-based acceleration. Normally, when you have something like a GPU, CPU, and FPGA, of course, we leverage that. But most of the times, customers don't necessarily have those powerful computers at the edge. And then we apply software-based acceleration through techniques like quantization, binarization, things like that. In other words, with the exact same CPU, small CPU with not so powerful number of cores or clock speed, how do you apply techniques like quantization, binarization, reduce and shrink the model, layers, the weights, and the speed and everything else to run effectively? We do that. And then comes the AI, which is, again, another buzzword. So what's AI really? Artificial intelligence. Normally what happens is when you go build a machine learning model, train it, deploy this into the edge environment, and it's perfectly predicting a failure condition, which is great. But what happens over time, just like everything else in life, things do change. There could be calibration issues, machine problem, behavior changes, something else, which will cause the exact same model that once accurately used to predict the results may no longer do that, may begin to drift. So we built modules as part of our software stack that can detect this degradation in the accuracy levels and then automatically start sending that raw data around that time period into a retraining module to automatically retrain the machine learning model, push it back onto the edge again, keep doing this iteratively until the accuracy comes back up to what it originally was, right? This is sort of an iterative closed-loop machine learning, effectively artificial intelligence, self-learning, self-healing, self-correcting behavior at the edge. This is what we mean by applying machine learning AI at the edge, as opposed to generally speaking, yes, AI is cool, and therefore let's go do that. But there is a real need for it, and there is a specific application of it in this context.
Okay, so I just want to be cognizant of our time here together. So how do you see adoption of edge technologies in the grand scheme of digital transformation?
It's actually a great question. So 4 years ago, obviously people were skeptical 4 or 5 years ago whether this is actually going to work. Initially, it always starts off as sort of POCs. Everybody is trying to test to validate whether this actually really does help them or not. In the last 4 or 5 years, we've done a number of POCs, hundreds of those with many, many customers. Now people have begun to realize the real value that it brings to. So now they're beginning to convert into production. The real challenges in this environment mostly is that it can't be a science experiment. There has to be a real business problem to be solved. The customers have to recognize that, right? There also needs to be alignment between the decision makers who have got the budget to write the check to the operators on the plant who actually are experiencing the problems day to day. There needs to be alignment. It's not enough if just the budget is available or the operator thinks that there is a pain. There needs to be alignment. So we normally watch out for these two signals to see if there is a real business value and if there is alignment, and then try to go in there. The third challenge typically we run into is this IT-OT divide. IT people obviously want to control software infrastructure and everything else, but the people who actually experience and be able to express what the problems are the OT people. How do you bridge the gap between the two? So our software, our solutions and tooling typically explicitly addresses that by providing the tools that allows the IT people to simply install them and configure them, and the OT people to be able to express what problems are they trying to solve, so both parties are actually happy and make it a friendly environment for that. But we see actually a huge adoption curve going forward now, especially what we have seen in the last 4 years. For one, in our own business, we're seeing a huge uptick in adoption of this across many industries: manufacturing, oil and gas, smart buildings, transportation, including autonomous driving vehicles, energy management across the building sectors, and so on. But I think the potential is huge.
Thank you. I've been speaking with Sastry Malladi, FogHorn.
Thank you, Greg. Thanks for having me. Appreciate it.